Good morning, Chemistry 12. Here's another example that we're going to look at today of mixtures of strong acids and strong bases. When you're looking at these mixtures, the first thing you're going to do is you're going to ooh, that was cute, calculate the moles of H+. Second thing you're going to do is you're going to calculate the moles of OH-. And then the third thing you're going to do is find the moles of H+ or OH- in excess. And then the fourth thing you're going to do is you are going to find the concentration of H+ or the concentration of OH-. Sorry, gotta close this thing down. There we go. Or the concentration of OH- by taking the moles of H+ or OH-, which were in excess, and dividing by the total volume of the mixture. Okay, so 4 steps. Number 1, moles of H+. Second, moles of OH-. Third, find whichever one is in excess. This is going to be easy because it's going to be a 1-to-1 ratio. And then finally, you're going to find the concentration of H+ or the concentration of OH-. Okay, so let's do an example here. We're going to mix, find the final pH when 50 milliliters of 0.200 molar HCl are mixed with 50 milliliters of 0.300 molar. Now let's make that point. No, that's fine. Barium hydroxide. I don't think barium hydroxide is actually that soluble, but we're going to pretend it is for our purposes today. So we are mixing HCl and barium hydroxide. We could write the entire formula equation for this. Formula equation, HCl plus BaOH2 gives us BaCl2 plus H2O. And of course, we would have to balance it. Okay, and so balancing this, we would need to have 2 chlorides. And so over here, we're going to put a 2 in front of our HCl. And we would need to have 2 hydroxides to balance the 2 hydrogens. And that means we're going to end up with 2 waters as well. Okay, our complete ionic equation for this, 2H+ plus 2 Cl- plus Ba 2+ plus 2 OH- gives us Ba 2+ plus 2 Cl- plus 2H2O. We'll cram that in the end there. Okay. Spectator ions. Well, barium is present on both sides and chloride is present on both sides. So we end up with our net ionic equation being 2H plus 2OH minus gives 2H2O. But we can simplify that down because everything is divisible by 2 into simply H plus OH minus gives H2O. And in fact, this is the net ionic equation for every single strong acid, strong base reaction. It doesn't matter whether you have two hydroxides in the compound or whether you have a triprotic acid. It doesn't matter. As long as everybody is strong, you're going to end up with this reaction here. This net ionic reaction is the net ionic equation for all strong acid, strong base neutralizations. Okay, and that's going to make our life really simple because it gives us a 1-to-1 ratio for how the hydrogen and hydroxide react with one another. So we're going to go back to our original question and we're going to do our fun stuff, which is number 1, calculate the moles of hydrogen. Okay, so that's the first thing we're going to do. We're going to calculate the moles of hydrogen. And the moles of hydrogen are going to come from our HCl. So we have 50 milliliters of 0.200 molar HCl. We have 50 milliliters of 0.200 molar HCl. And so our moles of hydrogen is going to equal, in fact, let's do millimoles to make our math easier. So we have 50.0 milliliters times 0.200 moles of HCl per liter. And that gives us, our liters cancel out. Right now we have millimoles of HCl. Okay, so we want to cancel then moles of HCl and find moles of H plus, and there is only one H plus in one HCl. So what we're going to get is we're going to get 0.2 times 50, so that's going to be 2 times 5, which is 10 millimoles of H plus. Okay, so we have found our millimoles of hydrogen. Now we're going to do the second thing that we needed to do, which is to find the moles of OH minus. We'll do that in blue because bases are blue, right? Okay, how much hydroxide do we have? Well, hydroxide is coming from our 50 milliliters of 0.3 molar barium hydroxide. So we have 50 milliliters of 0.300 molar barium hydroxide. So let's find our millimoles of OH minus. Okay, so we have 50.0 milliliters times 0.300 moles of BaOH2 per liter times, and let's see, we have, now notice here we have a 2 down at the bottom of the BaOH2, so we're going to have 2 moles of hydroxide for every 1 mole of barium hydroxide. Okay, And that's then going to give us, see, that's 5 times 3 is 15 times 2 is 30 millimoles of OH minus. So we've done step 1 and 2. We have found our moles of H. We found our moles of OH. Now the brilliant thing is that if we use this net ionic equation up here for our strong acid and strong base, our ratio of hydrogen to hydroxide is going to be 1 to 1. And if that's the case, then all we have to look at is say, who is the smaller amount here? That's going to be our hydrogen. This is the smaller amount. So we're going to use up all 10 millimoles of hydrogen, and we'll only be able to use up 10 millimoles of hydroxide. So hopefully that's obvious, right? Because it's a 1 to 1. So if we use 10 millimoles of hydrogen, we will also be using up 10 millimoles of hydroxide. Okay, and that means that we are going to have some of the hydroxide left over. Okay, so we're going to now do step 3, which is to calculate the moles of OH minus left over. And to do that, we simply take the moles of OH minus at the start, and we subtract the moles of OH minus used. So that's going to be, we started with 30 millimoles of OH minus, and we used up 10, right? 10 millimoles of OH minus, and so we are left with 20 millimoles of OH minus. Finally, we are going to, where did it go? Finally, what we're going to do is step number 4, which is find the concentration of the hydrogen or hydroxide. In this case, it's going to be our hydroxide that is in excess, and then we're going to divide that by the total mixture volume. Okay, so we have, that was step 3, this is step 4, the concentration of hydroxide left over is going to be 20 millimoles of hydroxide, which was the excess amount, or if you prefer, the leftover amount. So all we've got in our beaker now are some spectator ions and some hydroxide, okay, and of course water. Now what volume is that hydroxide in? That hydroxide is in, well, we mixed 50 milliliters and 50 milliliters, so it's going to be in 100.0 milliliters of solution. And this is where the milli is so lovely, because I've got milli up here and milli down here. I'm left with moles per liter, okay? And so we will end up with 20 divided by 100 is 0.200 molar OH minus, okay? And from that point, you would simply find the POH and then the pH, or you could find the concentration of hydrogen and then the pH. And I'm not going to show that step because it just makes things drag on a little long. Okay, I'm going to leave it there for today, and I'll see you again soon.